Good evening, everyone. So, my Scottish friend, whereabouts are you from? Dundee, excellent. So, before we get into it, I want to do a tiny bit of exercise, so forgive me for this. So, I had an accent when I was a kid. I had a Norfolk accent, and I want to teach you all how to speak Norfolk very quickly. So, repeat after me. Ha, yeah, right. Now, the quick key is the oi in there. Bo. Right, so, how you right, bo? How you right? So, how you right, boy? How you far got a dicky boat? No, he went to market and he got stuff off the roof, innit? Anyway, that's on the side. Anyway, I changed my accent because nobody employs country bumpkins. Anyway, so before Scape. So, who on earth am I? So that's the introduction for you all. I am Willem Koopman. I have a foreign name. I'm half Dutch. I am head of systems engineering or something along those lines at Scape. You've not heard of Scape because we're new and we have a generic logo. And always good. Branding is top. I used to work at the Financial Times. As a tech person, not a writer, obviously, because the cool I dress like. And before that, I was in the VFX industry, so high scale, lots of things with computers. So real steel, none of this cloud business, because that was too expensive. So who Scape? Now that's a valid question. Who do I work for and why? I'll give you a moment to digest that because it's all marketing speak. But basically, we augment GPS. GPS, especially around here, as you know, when you're trying to find the place, the circle of doom is 120 meters, 60 meters. And if you're trying to do AR or navigation or anything like that, that's terrible. We use a visual system to get you to about 20 centimeters. And crucially, where you're looking. We have a vision engine, which is a fancy way for saying a point cloud, to you that know. It's a digital representation of the real world. We have about 100 cities mapped. And basically, we use images. Images come in and maps go out. And as you can imagine, 100 cities, all the streets, that's quite a lot of data, which is the crux of the thing. And it's a server-side process, so data come to us, we process it, and we give you a position back. And this is kind of the rough representation. So we have point clouds, which are unique points that are global around the world. So at this point here, we know exactly that it's always in London on Maid Street or something like that. So when we take a picture and we have a number of these, we can work out where your camera is by solving the location. But enough of that, because that's marketing speak. Nobody cares about that. So enough sales. What infrastructure problems do we have? I'm lucky that we have a large data set, around about a petabyte, which is, it's a challenge. And we need to take all that unsorted data and turn it into something that's usable, because if you have data that you can't mine, well, it's just no point. So to get the bits of the data that we care about are the unique points in an image. So for example, that, if you all look behind you and the people on the camera, I apologize, you see all of this graffiti. We can guarantee that all of those pictures are unique to this building. So if we were to scan here and you take a picture of that, we know exactly where you are and we can scan you for that. But also crucially, there are people in the image and people move, so the cars, trees, and all that kind of stuff. So we have to get rid of that, so we have to do GDPR. That's to be complied with. And we have to work out the motion. Motion to that, render all these things. It's a lot of processing power. And then finally, we provide it to the VPS. Now, GIFs, everyone likes GIFs, I understand. Does anyone know where this is from? I assume you have children, right? Good choice, good choice. So, and can anybody repeat after me? Do you know what accent this bloke has? Anyone? Kiwi, so division. It's the key is division. Anyway, I'm sure we all enjoyed that. Now, so we need to define big data, more or less. We don't have Gartner in, so we have the next best thing, which is this lovely, lovely image of our Lord and Master Zuckerberg. Just look at him. Sorry, we have to make sure we don't get sucked in. Big data, so the definition of big data is basically the practical amount of data you can fit on one server and process. So as of now, it's about a petabyte. We'll go through the calculations. But so a 4U thing is about this big, full of 100 disks. It's enough to crush your foot if you drop it. We take away 20 drives because you need to make sure that data exists if you lose a drive. We have hot spares. So that gives you about 75 disks of 14 petabytes, because that's the maximum you can buy at a reasonable rate. So if we put that all together, that's about a petabyte. Now, if you connect that to a server, 4 lanes of 12 gig SAS, that's 6 gigabytes a second. So the crucial thing that you should all ignore, apart from this one bit, is it takes 50 hours to process, to read or write to that drive. So anything more than that, and that's kind of impractical or expensive or both. So look at that result. Oh, that's pretty vague. Therefore, big data is a petabyte, and for those of you who like Cookie Monster, Now, what does that mean? Stuff that I've done here. So I should have put this in a different order. So back in 2007, for those of us who are around, big data was 10 terabytes, expensive. My first file system was a Lustre file system, which was 100 terabytes, and that could put out 1 gigabyte a second. Oh, that's fast. Nowadays, that's one server, right? You know, these things move on. It's a moving target. But the important thing for this talk is that 1 petabyte, and we don't have quite a petabyte, just under, that makes Scape a medium data company. Always good. So, what does anybody care about? Nobody cares about the size of data. It's like teenage sex. We're all lying about it. So, we want to know, how do we process a large data set? So, we need to feed the data tubes. And as you can see, I worked in the movies, and that's why I still work in the movies, is the quality of art I've done here. So this, for those of you in the know, is how you make orange squash. And it's very similar to how our pipeline works. So we have the frozen oranges coming from all over the world, different qualities. So we need to blend it together. In data terms, we call that conform. Then we put it in the extractor. We get all the pip out, which is the features that we care about. We then send it to the map builder, which works out where they are in 3D space. And then we have the public API where we render it out to make it fast for it to be used. And as you can see, it's in one line, and there's clear inputs and outputs and control valves, and you can put it on the screen. It looks really cool, which is the important part. So pipelines, probably most of you have heard of pipelines. Hands up who's heard of pipelines. It's a fairly basic thing. For those of you who have had to support or look after Jenkins, I apologize, it's the same idea. But, sorry, whilst I do a one-handed opening, unlike Jenkins, this is easy to use. Sorry. So why a pipeline? What is the point of a pipeline? So as we defined it here, each stage does only one thing. That's crucial. It's kind of like a microservice, but less trendy. Like it's been around longer, and it doesn't have a logo. So each stage has one, or should have, there should be shoulds, I suppose, one clear input, a process, and an output. So those of you who grew up in kind of English-speaking countries, Ronsil, you've heard of Ronsil? Does exactly what it says on the tin. It should do that. If it does something different, it shouldn't be in the pipeline. And the other thing is, those of you who work in web, you're lucky because you don't have state. It's all still in the database. Somebody else looks after that. But we have enormous amount of state, gigabytes, terabytes of state. So we kind of have a limited choice. EFS, which for those of you who know is NFS, classy. But it's GPFS underneath the hood. So it's a proper clustered file system. And despite the terrible metadata performance, it's actually quite a good system when it works. S3, it's a key value store. HTTP, horribly efficient, but it works, it's cheap. And then finally a database, because sometimes having a database is good. Anyway, a diversion. So we have each stage, and it only computes, so the interface between each pipeline must be clear. If you can't tell the next stage that you need to run, then you failed. So we use SQS, because Kafka is a pain in the ass. Those of you who work in banking probably use MQ, again, pain in the ass. Kinesis, slow, terrible. SQS, it works, it's cheap, why bother? So, and also dependencies. We don't want the end of the pipeline where we render the API to start before we even have any data. So, clear order dependency. And then, for those of you who are old enough, statically compiled. So we go Morrissey.
Hello. So I've done stuff with audio, so.
So the important thing that we've all learned today is we have to turn it off and on again. So the crucial thing for deploying stuff is that we don't want to worry about dependencies. We just want it to work. So Docker, more or less, fails every time. But once you get it to work, it's great. But in the olden days, we'd static compile it, shove it in the zone for you Oracle people. Sonos you killed, but never mind. Chroot, if you're old school, or Jails, BSD, some people are beardy enough to run that, or containers. Now, can anybody tell me who my favorite Corsican is? Napoleon, good. Of course you would. I bow to the Frenchman in the room. Anyway, possibly one of the greatest military leaders in the world. But Scape pipeline history, you all want to know about the stuff I inherited, don't you? Yes, yes, that is the correct answer. So tell us more. So this is a slight rant. AWS, their icons are all the same. So I looked at a lovely diagramming service, but then it was just all orange with weird shapes. So as you can see, I'm an artist. I worked in VFX. You know, I worked on big movies. I worked on James Bond. Look, release skills. Anyway, so it was a linear pipeline, all manually created. So we had one vertical stack of autoscale group, EC2 instances, a cluster, a service, a task diff, an SQS queue, which then scaled up the next stage, and then so on and so forth. Now, who can see the problem with this? Well, many problems. Guesses, go. There's that. But I mean, the actual infrastructure problem. Number one, it's all manual, says the person on the phone. Good, it's all manual, that's the one thing. But crucially, if this fails, this side fails, and the back pressure, it's not clearing the SQS queue. So it continues to scale. So, you know, thousands of machines burning thousands of pounds a second. So, you know, we had to put loads of engineering in to make it work. Just tedious as hell. So, start again. Oh, I've done all that. Never mind. Ignore it. We did this. That's fine. I know what I'm doing. So what I need is a workload manager. And again, for the Oracle people at the back, paying attention. Do you see this logo? Yeah, yeah. You killed that. Sun, grid, engine. Ladies and gentlemen, the bastion, the thing that you all want in your pipeline is a grid engine. Now, those of you who are old enough might have remembered when XML was going to rule the world. You know, yeah. At the same time, grid engine was going to rule the world. Basically, you what, mate? It's fast. It basically you put an agent on a machine, it runs it, and you use Bash to submit stuff. Awesome. Even the developer can use it. They write a Bash script, and bam, stuff works. But XML. And the sad thing for me, I love shared storage. Like I had a GFS cluster when I was a wee lad. You know, but we don't have that in AWS yet. It's not cloud aware, so we'd have to put loads of triggers in. And it's run by Geneva. I mean, Jesus Christ. Anyway, and it's also 20 years old, which brings me to this. Look at that. Look at that. But I would like to draw ladies and gentlemen's attention to these tags here, because what does it say? Sony PSP. Does that not date it well? Anyway. 20 years, 1999. Right, nostalgic gift time. This is the most important part of the presentation. Can anyone tell me what's that? Dogma, yes, right. What's that? Come. Yes, Dawson's Creek, the best teenage drama in the world. Now, this is probably a bit more niche for those of us who are not from England or America, then maybe a bit of a challenge. Anyone? Yes. The finest, darkest, and the fact for you all is the comedy with the most amount of unique characters in there. Something like 190 something. No. Again, then everyone knows this, right? SpongeBob, slightly phallic SpongeBob. Everyone looks slightly phallic. But also, Futurama. Can anybody tell me what links them all? Possibly not all made by the same company. Yes, points for you, young man. Anyway, that was the end of the presentation. No, it's not. Right, so Back to the Future. That's a pun. I'm a dad. I can get away with this stuff. I apologize for nothing. Right, so this is where I try and fail at throw shade and show my ignorance. So when I was evaluating what workload manager I was going to use, I went through a couple of things. Now, I didn't really pay attention to who else was speaking, and you'll see where I'm going to cack my pants because I make some assertions about a certain technology, and they're probably not going to be true. So anyway, ignore that. I hear Kubernetes is good. Now, I can imagine half of you are like, yeah, I want to run Kubernetes, right? No? Good choice. Well done. Right, so the important thing for us is it's good for the CV. This is the most important thing. You put Kubernetes on your CV, and that's an extra 20 grand, right? It's the most important thing. CV-driven development, as we all know, is the best way to proper architecture. It also, I mean, the other thing is cloud aware, more or less. but it is extraordinarily chatty. For a thing that claims to be cloud aware and a thing that claims to scale infinitely, has anybody ever managed to get it past 500 nodes? No? Because you can't. Because you have to do so much stuff. It's stuff that, like they give this spiel about how, oh yeah, Google uses it. Bollocks, do they? I mean, gee, like, it doesn't go fast, do Anyway, so I tried and I failed. The other crucial thing is those of you who have run a distributed system before, you now have 5 problems. No, 2 problems. Oh no, it's back to 0. A distributed system is extraordinarily hard to look after. It's an elastic thing. You poke it one place, stuff comes out the other way. Just, at the time, I was the only DevOps. I don't want to be looking at this at 4 o'clock in the morning. The other crucial thing, probably, if we can ignore all of this, apart from this one last thing, is that a task queue, which is used for batch processing, doesn't actually have dependencies. So if you want to make sure that one thing runs first, then the other, you can't do that. You can have a sidecar, and you can have a preliminary, but a long chain of arbitrary numbers, you can't do it natively. So you have to use Argo, which is all right. But then you've got another plugin to maintain. So I'm being looked at by my esteemed French colleague to say I'm talking bollocks. So I will defer to him when he says that I'm talking shit. But the hill I will die on is this. 90% of the networking modes are batshit insane. Absolutely batshit insane. Let's reinvent DHCP. Really? Let's reinvent routing. Really? Let's statically assign 256 IPs per node. Because that's going to scale, isn't it, kids? No. VLANs were made for a reason. They were made before all of us were born, and it works. Right, I see I've lost the room. Right, Calico, the Swift, the virtual tunnel, the concept of high-performance computing, where you actively use CPU cycles to encode stuff, encrypt it across the network that you already own. Just why? Why add that latency? Just no. Like, I understand. Yeah, okay, right. An esteemed colleague has said, let's use OpenStack. Well, we could. I mean, it worked well for The Guardian. I mean, they're making money now, right? So that was, and also the upgrade cycle. Right, so that's enough rants. Judge Judy, have a look at Judge Judy. I like that GIF. That's an evergreen GIF. Right, so this is where it all comes to falling down like a sack of shit, because the third speaker is going to talk about Mesos, I think. So where are you? Is this all this lies? Good, excellent. Right, I made a good choice. Right, so Mesos has a stronger pedigree than Kubernetes. It's older. It's a proper resource manager, so it means that you can do things like have queues that have to land on certain machines. So if you've got GPU, you can say, right, tag this job with a GPU, tag this next task with a CPU, this has to have so much RAM. That's good. And there's lots of fine-grained resources to say, right, if this job is tagged as really, really, really important, don't preempt it with someone's dev stuff. That's useful. But the documentation is terrible. Like, it's an Apache project, so you're never going to get help there. It requires quite a lot of integration. AWS at the time was a bit lacking, much less useful than Kubernetes. And this needs to die. MapReduce, it's a terrible idea. Fork, kids, fork, it works. Just, anyway, right. Rabbits. I recommend rabbits as a house pet. Seriously, they're brilliant. Look at it, it's chewing. Look at that. Anyway, right. So this is a valid point. I think I can feel in the room smart ass is a fair assumption of what I'm saying here. So yes, what did I choose, children? What did I choose? Anybody know what that is? Yes, AWS something. AWS something, that's the point. AWS something. This is actually batch. Again, look at that typography, VFX. So what is batch? Basically, it's a thin layer over ECS. It's free. I like free. We're all DevOps, we like free. So this handles, so it means that this sentence means that we can say, right, I want to run this one first, this one second, this one third. If the middle one fails, don't run the third one. Don't waste my money, which is really important. It's hosted, which can be a good thing. Automatically scales thing. I don't have to worry about scaling. It does it for me. Good. No things for me to do. It's simple, as anything else can be in AWS. This is actually true. GPU support is actually easy to do. You give it a machine that's got GPU, done. So, and the most important thing is the difference between scaling to 20 machines and 2,000 machines. A is an email, because they'll say you can't do that. But the next one, after you've got the email, is to say, I want 2,000 machines. You cannot do that with Kubernetes without hiring a consultant, rewriting your pipeline, and generally losing £14 million. FT, as we were. Right. And also spot fleets, because we don't want to spend loads of money. But there are a few downsides, like the clicker. There we go. The UI, as with everything AWS, the UI is just diluted horseshit. The submitting jobs, also, this is the thing that's really crucial, is that it's fine if I can use it, but if my developers cannot, I have failed as a person, and therefore I am useless. Again, documentation, AWS is a bit patchy in this. Sometimes it can be brilliant, but most of the time it is not. Extremely dense. I mean, this is one thing that Oracle does do really well. Much as I've been there, their documentation next to IBM is spectacular. I all ask you to read an IBM Redbook. So you may laugh, but IBM Redbook will tell you everything you need to know in real English, not just developer English, actual real English. If you don't have a degree in computer science, you can read this stuff and understand. Seriously, it is beautiful, and yet you still have IBM consultants who don't know what they're doing. But never mind. So we have to build our own tooling, don't I? Yes, we do. Everyone has to build their own tooling. Have a nice gif of that. So, you see, nobody likes YAML today. But, right, those of you who are gifted with sight and therefore young may be able to see. So we have 3 or 4 sections. At the top, we have who the owner is. I'm Willem, that's my name. Then the pipeline, and then a few other things. But crucially, we can say for the entire job, some environment variable, like please don't die on me. That's always a good one. Then we have the first job called chop. This is the name of the Docker container you want to run. And then we only want to run one of them on the GPU with nothing else before it. Fine. Next one's a bit more complex. We want to run an extractor. The job is called an extractor, so the container we want to run is called extractor. It depends on this one first. We want to run this bash command, then this one, then this one. None of this Docker, Docker run, blah, 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 bin bash -c, blah, 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 blah. Oh, wait, we don't have an environment, do we not? No, it's just bash. Now, I know most people don't like bash, but this makes life so much easier. Environment variables, I want to run 400 of those. I want a memory limit of 3.5 gigs, and I want 12 CPUs for each one. This is much the same, but on a GPU, who cares? But this is the thing. It is simple. My developers, I showed them this with the documentation, and they did things that I didn't know were possible. It's so simple. I say, I want to run this Docker container, then this one, with this bash command in. No more stuff. That's all you want to do. So ignore this because I've just talked over this, blah, 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 blah. Again, practice makes purpose. Right, also, anyone know who this is? Scrubs? Good, yes. We all need to watch Scrubs more. Right, so everyone wants Slack alerts. So you submit a job, you don't know what happens because it's AWS, the UI sucks. So you submit a job, it tells you the job name, the file. I submitted the job, and it's called this one. If it fails, you get an alert. But crucially, when you have 14,000 tasks, you don't want 14,000 alerts. I discovered that the hard way. So this runs every 5 minutes, it rounds it up, so you get a kind of a précis of your failure, which is always fun. It's kind of, this is your real life, but not quite. And also a better GUI, there we go, I can speak. Crucially for us, so when the one key failing of batch is the interface, so you click on the batch interface and you want to see if a job's running, it'll say it's pending even though it's running. Good GUI there. So anyway, we put everything into a task, and then you click on it, you can see how individual tasks are running, how much time it's taking, you can terminate individual bits, all the whole lot, and more importantly, I discovered Unicode. You know, you can put Unicode and stuff. This is good, right? We should all put Unicode in. But spelling is optional extra. It adds, what should we say, charm. It's like patina on a fine watch, right? You know. Anyway, the future. So I have bored you thus far. So what will we do in the future? This is kind of the state of computer graphics now. These are all on SGI machines. Those of you who are lucky enough to use them. Anyway, so AWS, despite hating everything kind of distributed for the consumer, they have released this thing called FSX, which is Lustre. Anybody heard of Lustre? It's a file system that's really, really fast, but like RAID 0 on the network, so ultra reliable. Anyway, so they have a service that we can use, so we can make a proper actual mainframe with its shared backend, with shared memory, and a shared file system that runs at 40, 50 gigabytes a second. And it's cheap, like $200 a month gets you shared storage of 3.6 terabytes that you can use over 1,000, 2,000, 10,000 machines. Compare that to EBS, or doing something stupid like using Gluster with a G, or Ceph. I mean, Jesus Christ, Ceph. Anyway, and we also need to make sure better billing. So we know how many hours it takes, but we don't know how much that costs. So we need to do some maths, but I'm not a data scientist, so that's their problem. And also, the one thing I'd quite like to do is running long-term loads on AWS, as you all know, is hilariously expensive. So the more long-term stuff on the trick to run on real steel is just a Docker image. So if you provide kind of some metadata, it kind of does work, but it's not reliable. Then, yeah, anybody know where that GIF's from? Yeah, that's the good part, right? Sorry, it is from Hal. Sorry, not Hal 9000. It's from Space 2001. It's where Hal kills all the astronauts, which is always a fun thing to end on. Anyway, we're one step closer to the mainframe, which is basically the only reason why I became a DevOps, and then they killed all the mainframes. So, more for me. Anyway, conclusions. We're getting there. This is almost the end. Hold on. High scale and medium data pipelines are possible in AWS. We kind of knew that, but again, kind of teenage sex thing. Hopefully, I proved that, you know, this happens. We can do it cheaply. We genuinely can. Like to render a city, it's less than £10,000. Yeah, that's quite good. We can do it simply. Like as I said, developers do it on their own. They don't need to talk to me. They do it, and when it breaks, they come and talk to me. And that's fairly rarely because it's AWS. But you need to create a user interface because theirs is just dog shit. Again, AWS, please take away the JavaScript. Just make it load fast. I don't care about the extra bit. Make it fast. And then this one, I wish this was mine, but I found it somewhere else. Kubernetes is like a waterbed. Everyone wants one. It's great. It's a bit heavy and wobbly, but then it breaks and it stretches everyone and leaves a very bad smell afterwards. So as you can see, I'm going to KubeCon. Anyway, and then do we have questions? I'm sure there are some, or maybe none. Come on, don't be shy. Ooh, yes, you. Does that? Oh, sorry.
Does something.
Okay.
Who did you avoid somewhere?
Thank you for the talk.
No problem.
So besides pressing buttons randomly on the web console for AWS, did you do any part of structuring this into codes?
Yes. So it's all driven by CloudFormation. So batch is, what, 4 or 5 stanzas of CloudFormation. The ancillary stuff is 5 or 6 lambdas and a database. So that's all in 2 CloudFormation templates because, you know, I'm cool and I haven't used Terraform yet. So we'll get there.
Do you need to take care on which kind of instances are you using?
No, that's the really nice thing. So you have a compute environment. You say that I want to have this type of computer. So you can say a range. So you can either have it specific to you want a T2 micro, you might, or you can say an entire class. So you can say C4, C5, whatever. So we have two things. GPU queue, which has just one type of instance, and then we have R4s and C4s because they're cheap and fast.
This still works.
This sort of works as well.
Hello.
Hello. Is it me you're looking for? I can see it in your eyes.
Do the instance had to go on the normal ones or can go into spot instance?
So they're all spot because I'm sadly not made the money. You can see by my clothes that I don't work in banking. Yeah, no, so you have a choice. At the start, you either say you want it spot or you want it on big money. We have it on spot because we're a startup. So yeah. Dom at the front. Ooh. I'm sorry, I tried.
Thank you. I imagine that you can retry on a stage if it failed.
You'd think. So the one downfall of batch is that how failures are handled. Basically, if for any reason something terminates, that's it, and the whole pipeline fails. So you can say, I want when you define a task, you can say I want to run a maximum of 4 times before I'm marking it as failure. So you have to make it is it idempotent? Is that how you pronounce it? Yeah, run once basically.
So do you have enough information to debug?
Yeah, I mean, so you're stuck with CloudWatch, but I mean, if that's enough information, again, that's how, so everything. So interchange between the stages is all in SQS. So with the CloudFormation and the unique ID of the message, we can work out what the input was. And normally 9 times out of 10, it's basically, it's a spot instance, it was taken away and it was killed. That's fairly obvious, that's a different thing. But if it's a specific memory instance or out of memory, then we can rerun it again and see what happens.
Okay, since that you have solved an important problem, what was the major challenge then?
Just ironing off the edges. So the people, I'd never worked with this before. So making the interface usable for people, writing the documentation. I mean, I know it's not sexy, but most of the hard work was done by AWS, which is why we pay the money. So most of it was human, pressing the flesh. Like, use my system, it's great. Look, it's really simple. That was basically 90% of it.
Great talk, thanks.
Thank you.
Is there anything open source that we can look at?
Soon. So yeah, so we, on the one hand, I'm quite proud of this, but on the other hand, if you could see some of the hacks, I would be less proud. So
We can, well,
we
we
will
can create pull requests.
So yeah, no, I mean, so one of the things I wanted to do is make it so that you could more or less deploy it as a whole. Because it's a bit tied into our pipeline, we want to make sure that it's universal, so someone can actually go, right, I can use this. Oh, it's great.
Yeah, works out
Yeah.
of the box.
So in maybe 4 to 5 months, there's a Jira ticket and it's high priority. It will happen. I want to do it because you know it saves people time. It's easy to use, more or less.
Do you do stand up, and if not, why not?
So
Do you do stand up, and if not, why not?
well, I don't, but I'm petrified that I'm going to say something offensive. So I try not to be in public as much as possible because you know I could live stream my end of my career by saying something quite controversial. So
I think if you do stand up, that would probably be like expected to be controversial and inappropriate.
Maybe. Well, how about that Brexit? Eh? No,
Give a round of applause.
thank you very much.